Alright, hello everyone, this is Mr. Carter. I'm going to go over our first practice test with you, go over all the answers and some work here. Problem number 1 says find the arithmetic sequence. Well, we can just write this as a linear equation. We have a slope of 3, you can see that there, and our first point is 7, so I can put the 1 in for the x value, 7 in for the y value. I can write this equation here and then just plug in 30 and I will get 94. So just treat it like a linear equation and you will get it. Number 2, on the interval, the rate of change is negative, so that means the graph is going down, and it's decreasing, so it's also concave down. So that's what the graph looks like. It's a concave down graph. On number 3, estimate the interval where the rate of change is negative, but it's increasing. So in this case, I want negative, but I want it concave up. So that's just going to be this little section right here. I'll highlight it in yellow. From there to there, that section is negative, and it's going up, concave up. And that goes from about -1, somewhere in here, to about 1.4. You can just estimate on these. These numbers don't have to be exact. Alright, on the bottom one, we're going to treat this one right here, and we're going to find the rate of change in between here. So from 67 to 90, if I subtract that back, it's up 23. But be careful, the change here is 3, so it's 23 divided by 3, 7 2/3. This one is 13 divided by 3, 18 divided by 5 up here, and this last one is 19 divided by 3, because that's a change of 3. The highest rate of change is the first one. Alright, on the graph here we have a point of inflection, C. Points of inflection are where two concavities meet, a concave down and a concave up. Alright, problem B is a relative minimum. That's going to be D. It's the bottom of a valley. A global minimum means the lowest point in the whole graph, and that would be point A. Increasing intervals are when it's going up, and that's this section here and this section here. And again, I label them by the x values from about 0.8 to 2.8. It's going up, and it's going up here. Concave up intervals are when the cup is facing up, concave up. And that's all this section right in here from about C to E, that direction there. Which rate of change is the highest? Well, in this 3x period, it goes up 8. 3 times 8 is 24. This is an interval of 5. 5 times 5 is 25. This is an interval of 4. 4 times 7 is 28. The average rate of change here is just an estimation. You estimate at point -2, which is here, to point 1, which is there, and you're looking for that slope. So I have it's dropping about 3.2 over 3, so I had a slope of about -16/15. But again, that's just an estimation, so it doesn't have to be exact. Alright, on problem 8, I found the intercepts. Plug in 0 for x. That makes y -10/3. Plug in 0 for y. X is 5. Plot the points, and there's your line. Number 9, in July, which is right here, the rate of change is going up, so it is going up here, but it is concave down on that point. Number 10, finding the equation of a line. Again, there's our point slope formula. Y minus y2 equals the slope x minus x1. I went ahead and moved this over to this side, so now I can just plug in 8 into this equation, and I will get 14/5. On number 11, you have a piecewise function. You have to plug -8 into the top line, 4 into the bottom line, 1/2 into the middle line, and do the math. Now remember, 9 to the 1/2 power means the second root of 9 to the first, which is the square root of 9, which is 3. The difference quotient, we write it all out using this expression right here. Do the math, simplify at the end. I divide all of these terms that are left by h, and I have 4x plus 2h minus 1. Number 13, another linear equation. You want to get in a habit of learning this formula. Y minus y2 equals the slope x minus x1, or y1 minus y minus y1, x minus x1, however you want to look at it. Just put the y value here, put the x value there. Found an equation. This did ask for the slope-intercept form, so you want to put it in y equals mx plus b. Then you can put in 200 on the left-hand side, solve the equation. Alright, number 14. When is the graph going from decreasing to increasing? Well, decreasing to increasing is a minimum. So right here we have a minimum at about 13.2. But when is the rate of change going from negative? So the rate of change, not the values, the rate of change is going from decreasing, which would be concave down, to concave up. That's that point of inflection about right there. So this is asking for a minimum. This is asking for a point of inflection. Two different things it's asking for. At 3, the graph is increasing. Let's see, let's go ahead and put it down at 3. Right there, the graph is increasing, but it's concave down. Alright, when you're graphing a absolute value, take this middle section here out, solve for the vertex. So the vertex is at 3. Plug in the values, do some numbers on the left, do some numbers on the right, and it will be symmetrical, so it will line up perfect. The domain goes from negative 2, actually it's a little bit past negative 2, let's put negative 2.5 on there, to about 3, about negative 2.5 to 3. The range, the lowest range down here is about negative 10, but it does go up to 16. Increasing intervals. It's increasing here and there. Relative minimums is the bottom of this hill right here, 0, 0. Relative maximum are these 2 points here. They're the top of a hill. This is a valley. I like to think of a minimum as a valley and a maximum as a hill. And again, a point of inflection where the two concavities meet. And in this equation, you're going to have 2 of them. 1, 2. So right in here and right in there. And I'll go ahead and draw those concavities on here. Here's one that's facing down. Here's another one that's facing down. And the one in the middle is facing up. Even and odd. If you plug in negative x to this equation, you'll get this expression. If you factor out a negative 1, these do not match. So nothing matches here, meaning does not have any symmetry. On the bottom one, however, if I plug in negative x here, what you'll see is I'm right back to where I started, which means it's an even function. On the back, find values where f of x is 3. The 3 goes there, then you can move it over. You can solve this by factoring, or the quadratic formula will get there. Average rate of change is just slope. Take your 2x values, plug them into the equation, get the corresponding y values, do the slope formula, you'll have your slope. Finding the zeros, set it equal to 0, solve the equation. Same thing here, set it equal to 0, solve the equation. Same thing on 23, set it equal to 0. Now when you solve this equation, all of this gets moved over to here, so now I'm just left with this equation, which solves to x is plus or minus root 2. The domain. Well, we cannot divide by 0. So the domain is all real numbers as long as the denominator is not 0, and that would be plus or minus 4. On number 25, we cannot take the square root of a negative number. So the domain is all real numbers as long as this denominator, or this number under the radical sign, is greater than 0. We can solve it to x has to be less than 2/5. And slope formula again, point slope form. Find the slope right here, and then you go ahead and plug it in with the y point and the x point. There's a formula. You can use this one, or you can use this bottom one. They both mean the same thing. Alright, hope this helps with your homework.